So my team members and I got number 10, which asks to factor completely and find exact value of all zeros, real zeros, and we are given 1, 0. So the function is f of x equals x cubed plus 7x squared minus 15x minus 81, with a given factor of x equals -3. Since we were given a factor and it's equal to, we don't change it and we put it outside a box. So -3 is placed outside, and inside of the box we place the coefficients of each term. So x cubed would be 1, 7x squared would be 7, -15 would x would be -15, and -81 is -81. So once they're inside, we first bring down the 1, and then after this, we follow a pattern that multiplies the number outside of the box and then add to the next coefficient. So it'd be 1 times -3, which is -3, and then 7 plus -3, which is 4. And we keep doing that. 4 times -3 is -12. -15 plus -12 is -27. And -27 plus times -3 is 81. And -81 plus 81 cancels out, turning it to 0. In order to get, with these numbers, we can get a new function by just ignoring the first part here. And we get this number here as our term with no x, as a single term, basically. So we bring it down, we get -27. And then here, the next term would then have an x. And the next term would have another added x. So it'd be 4 and an x, which brings down to 4x. And then the next term would add another x, so it'd be x squared, doubled here. So with that, we get a new function, which is f of x equals x squared plus 4x minus 27 and x plus 3, since it's from x equals -3 and it's the opposite.
Hi, my name is Cassidy, and I'll be explaining the rest of Part A, which is to find all the zeros and factor anything else. So, my team member Giselle did the first part of Part A, which was synthetic division, and she landed on this new function. The x plus 3 was the factor given to us, but the new function she found was f of x is equal to x squared plus 4x minus 27. So I have to factor this out. I knew that the area model wouldn't work. Well, I tried it and it didn't work. So I knew the next step, or the next method would have to be the quadratic formula, which I put up here. So my first step with the quadratic formula is to make the function that we found equal to 0, which I did right here. And then I plug in my values from the function into the formula. So a equals 1, which is symbolized right here with x squared. B equals 4, symbolized by plus 4x. And C equals minus 27, which is right here. So I inputted that all into my quadratic formula, which can be seen right here. So -4 is plus or minus the square root of 4 squared minus 4 times 1 times -27. After that, my steps just included simplifying. So I simplified this right here, and ultimately in the end I got to -2 plus or minus the square root of 62, which then was able to simplify even more, which I got -2 plus the square root of 31 and -2 minus the square root of 31. So these were our other factors and zeros, which I put right here. So this is the factor given to us. This is what I found, and this is the answer of our x's and zeros.
Hi, my name is Frankie, and I'll be working on 10C. We will be factoring, simplifying, and finding the exact values of the following polynomial function. So C says that g of x is equal to x to the fourth minus 5x to the third minus x plus 5. And we are given that one of the factors is x is equal to 5. Okay, so below that I have my work. So my first step was to write out the polynomial function. My next step was to include and put the missing degrees or powers that weren't included in the polynomial function that was given. Okay, so as you can see, I included 0x squared because it was not included, right? My next step was to write out all the coefficients of every term. So as you can see, 1x to the fourth minus 5x to the third plus 0x squared minus 1x to the first and plus 5. So now that we have all these coefficients, I brought them down. So we have 1, -5, 0, -1, and 5. Okay, now we're going to use this factor that was given. X is equal to 5, and if we don't know where that came from, that means that one of the factors, right, it must have been x is equal to x minus 5. And why is that? And that's because when we set that factor equal to 0 and we get x by itself, we get x is equal to 5. So this is true. So because we're given this factor, we know that we're going to be doing synthetic division. Okay, so we get our 0, x is equal to 5, right? We put it into this little like seat for it to sit in there, and then we write out our coefficients as it is written from left to right. So 1, -5, plus 0, minus 1, plus 5. Now we bring down the 1 down, multiply it by the 0, or our x is equal to 5, and then we put it next to underneath the -5. Add them and then multiply again by the 5. So we're going to repeat this process. Now we have x to the third, 0x squared, 0x minus 1 plus 0. Now our final equation will be g of x is equal to x to the third minus 1, x minus 5. So when we do the math, first we bring down the 1, multiply it by the 5, which is our factor, and then we put it in the little space underneath the -5, add those together, bring it down, which is 0, multiply that by the factor, and we repeat that process over and over again. Now we write it as x to the third instead of x to the fourth because we are already using one of the factors. So you see this in a second. You'll see why, like what I'm talking about. So we have x to the third plus 0x to squared plus 0x minus 1 plus 0. So once we simplify that down, we have g of x is equal to x to the third minus 1 and x minus 5. See that x minus 5 is that factor that we were given at the beginning, and the factor that we were also using to divide in the synthetic division. And I know this is true. I know this works because if we were to multiply these two factors together, the highest degree that I can get to is 4, which is the same degree as a polynomial that we were given at the beginning. See, the highest degree is 4.